Hello everyone, in this video I'm going to discuss the example for vector. Kindly refers to the questions. If the line named L1 with the vector equation r is equals to with the point 1, 1, 2, t with the vector 2, negative 1, 3 does not intersect with the plane with the name pi1 ax plus by plus cz is equals to 0. Kindly show the situation. We have 2a minus b plus 3c is equals to 0. Hence, find the equation of the plane named pi1 if the plane passes through the point 1, 0, 1. So first, kindly rewrite the situation for the line L1. And we have r is equals to bracket 1, 1, 2 plus t bracket, we have the vector 2, negative 1 and 3. Next, we have the pi1 named ax plus with the by plus with the cz is equals to 0. Continue, they said does not intersect. Means that we have to make use of the direction where we have the direction for the line L1 and also the normal where we have A, B and C. So kindly dot the situation 2, negative 1 and 3 dot with the situation A, B and C equals to 0 because does not intersect. So from here dot the situation 2A minus with the B plus with the 3C is equals to 0. So from here we already shown the situation. Hence, find the equation of the plane named pi1 if the plane passes through the point 1, 0, 1. So what we have to do is to substitute the point into the equation of plane. So we will have A, then 0 for the y, and then we have the z, which is plus c equals to 0. So kindly rearrange the situation where we have A is equals to negative c. Substitute the equation A equals to negative c into this part. So we will have negative 2c minus with the b plus with the 3c is equals to 0. Then finally we will have the situation c minus b is equals to 0. So c is equals to b. So from here we notice that we have the situation A is equals to negative c. So from here we have the situation C is equals to B. So from here, C also equals to negative A. So let's say if C is equals to negative 1, then we will have B also equals to negative 1. Finally, A is equals to 1. So finally, we can substitute the value for A, B and C into the equation for the plane named pi1, where we have the A which is equals to 1. So x minus y minus z is equals to 0. So kindly refers to the question, given the line, we have the name L2. So where we have R is equals to X naught, Y naught, Z naught, where we have the point. Plus, we have T with the direction, named V1, V2, and V3. So that is the situation for the line L2. We have the vector equation. Continue, we have the plane, named pi2. So where we can have the r, which is x, y, z, and with the normal, where we have 1, negative 1, and 2, equals to 0. And the question said, the point x naught, y naught, z naught cannot be equals to origin. It's on the plane. So if L2 is perpendicular to the plane pi2. So kindly imagine the situation. Here, let's say we have the plane pi2. And then as we all know, for the plane pi2, actually they have the normal, named 1, negative 1, and 2. Then kindly refers to the question again. They said L2, with the blue in color, is perpendicular to the plane. So that will be the situation. So here we have the line L2. So as we can see, the normal actually is the same, or we can say parallels to the line L2. So meaning that from here, we notice that V1, V2 and V3 actually is equals to 1, negative 1 and 2. So the question asks us to show that V1, V2 and V3 is equals to V2 multiplied with the vector negative 1, 1, negative 2. So means that what we have to do is to factor out the negative 1. Because the negative 1 shows that we have V2 is equals to negative 1. So kindly factor out the situation. So V1, V2 and V3 is equals to negative 1, bracket. Again, we have negative 1, 1, and negative 2. So kindly refers to this part. And we notice that we already shown the situation where the V1, V2, and V3 is equals to V2, where we have negative 1, bracket, negative 1, 1, and negative 2. So from here, we already shown the situation. Next, give one example of the equation of a straight line. So the focus is the straight line, which satisfies the part above. So means that what we can say is to find the L2. So given the previously, we know that the normal actually is the same with the direction of the L2. So in here, we can say R, bracket, x0, y0, and z0, plus t, bracket, we have the V1, which is equals to 1, negative 1, and 2. So that is the situation. So the most important thing is we have to give an example so that we can show that the line is on the plane. So from the diagram, we notice that the line actually intersect on the plane. So as we can see, here we have R dot with the N equals to A dot with the N. So meaning that the A dot N must be equals to 0. So kindly refers to the situation. Here we have the A, x0, y0, and z0. Dot with the situation, we have the normal. So in here we have 1, negative 1, and 2. So remember, must be equals to 0. So question asks us to give one example. So meaning that we are interested in looking the point A, which is the x0, y0, and z0. So we can assume that, let's say, we have x0 minus the y0 plus with 2z0 is equals to 0. For example, let the x0 as a 1. So try to imagine the situation. If we let the x0 as a 1, then also the z0 also as a 1. So for sure, in order to make the situation become 0, we have to find out the situation y must be equals to 3. So that x0, 1 minus with the 3 plus with the 2 is equals to 0. So that is one of the example for the point A. So from here, R is equals to, bracket, 1, 3, 1 plus T, bracket, we have 1, negative 1, and 2. So that is the example of the equation of the straight line which satisfy the plane above. Or we may put another example. For example, we let the x0 as 2. Then the z as a 1. So if the x0 as a 2, z as a 1, so kindly refers to the equation where we have 2 plus with the 2, so the y must be equals to 4. So that will be the point 2, 4, 1. So equation of the straight line will be R is equals to 2, 4, 1 plus T, bracket, we have 1, negative 1, and 2. So that is another example. So here we have the situation for the questions. Thank you so much for watching this video. If you think the video is useful, kindly consider to like, comment, share, and subscribe.